we are done with the basics of nodal analysis, and now we are going to solve our problem number 1 on nodal analysis. And according to this problem, we are required to develop the nodal equations for the below given electrical network. You can see the network on your screen, and we are having 1, 2, 3, 4 and 5 resistors in the network, and there are 2 independent sources. This source is the independent voltage source providing V volts voltage, and this source is the independent current source providing I amperes of current. And by the nodal equations we mean the KCL equations for each non-reference node. So we need to develop the KCL equations for each non-reference node for this electrical network. So let's move on to our solution, and we know in step number 1 of nodal analysis we identify the total number of nodes in the given network, and in this network we have one node here, second node is here, third node is here, and the fourth node is here. So in total the number of nodes is equal to 4. So we are done with step number 1. Now let's move on to step number 2, in which we will assign the node voltages and we will choose the reference node. Let's say this node, and this node are the non-reference nodes, and this node here is our reference node, and we know the voltage at the reference node is equal to 0 volt. Therefore we have connected ground to this particular node, or you can say we have grounded this node. And we know the fact the reference node is usually the node where the maximum number of branches are connected, but I told you to forget about this point and simply choose the bottom node as the reference node. So this node here is our reference node, and let's say the voltage at this node is equal to V1, and this node is having the voltage V2, this node is having the voltage V3. So we are done with step number 2. Now let's move on to step number 3, and in this particular question we need to perform the nodal analysis only up to step number 3. Step number 4 is not required because in step number 4 we solve the KCL equations or the nodal equations, but here we only need to obtain or develop the nodal equations. So this step is our last step, and we know we develop the KCL equations for non-reference nodes, and here we are having 1, 2 and 3 non-reference nodes. So let's begin with first non-reference node, that is this one. So at node 1 we will develop the KCL equation, and for that we will first mark the currents in different branches connecting at this particular node. Let's say current in this branch is equal to I1, current in this branch is equal to I2, and in this branch current is equal to I3, and we are considering V1 to be the largest voltage. Therefore we have taken the direction of currents outgoing. We already know this point. Now according to KCL, the sum of outgoing currents must be equal to the sum of incoming currents. Here there are no incoming currents, therefore the sum of incoming currents will be equal to 0. So finally we can say that current I1 plus current I2 plus current I3 is equal to 0. And from Ohm's law we know that the current is equal to the voltage divided by the resistance. And if you focus on current I1, you can see that the voltage, that is the potential difference, is equal to V1 minus V3, because current I1 is the current in this branch and these two nodes are the nodes across this branch. Therefore, the potential difference will be equal to V1 minus V3, and we are taking the potential difference as V1 minus V3 and not V3 minus V1, because while writing the KCL equation for this node, we will consider the voltage of this node to be the largest. Therefore, we can say that current I1 is equal to V1 minus V3 divided by the resistance R5. Following this similar approach, we can say that current I2 is equal to V1 minus V2 divided by R2. V1 minus V2 divided by R2, and current I3 will be equal to V1 minus 0 minus V divided by R1. V1 minus 0 minus V divided by R1. To have this, we have followed the KVL, and in the previous lecture I gave you the rule to write this down directly, so we will not waste time into this and we will simply write down V1 minus 0 minus V equal to V1 minus V. So in this way we have obtained the KCL equation for the first node, and now we will move on to node number 2. So at node number 2 we have voltage equal to V2, and let's say this current is equal to I21, this current is equal to I22, and this current here is equal to I23, and following the KCL we will have I21 plus I22 plus I23 equal to 0, and I21, this means this current will be equal to V2 minus V1 divided by R2. Then I22 will be equal to V2 minus 0 divided by R3, V2 minus 0 divided by R3. Then current I23 will be simply equal to I, because this current and the source is having the same direction. Therefore, we will write I in place of I23 equal to 0. So this is the KCL equation or the node equation at node number 2. Now we will write down the KCL equation at node 3. Here we will again assume the currents. Let's say current in this branch is equal to I31, current in this branch is equal to I32, current in this branch is equal to I33. Now following the KCL, we can say that at node 3, I31 plus I32 plus I33 is equal to 0. Now it is homework. It is homework for you to write down all the 3 currents and have the final nodal equation at node number 3. So try to obtain the equation, and once you have your answer, post it in comment section. Now I will end this lecture here. See you in the next one.